Integrated development environments have proven nearly essential for software development, but are virtually non-existent in digital knowledge work. The WorkTop tool suite streamlines finding, exploring, annotating, sharing, and publishing media-rich documents. WorkTop combines pen, touch, and traditional WIMP input to support devices from tablets to workstations to electronic whiteboards. The foundation of WorkTop is an unbounded zoomable 2D workspace where documents of any type can be freely arranged. Documents can be edited directly or for more control, modified with a specialized external editor like Microsoft Word. Unlike traditional desktops, all WorkTop documents, including widgets, maps, videos, PDFs, and web pages, are live and interactive. Any part of a document or video can be explicitly linked to other documents with fine-grained bidirectional hyperlinks. Clicking on a link endpoint toggles the display of its target. Simple drag-and-drop operations establish persistent hyperlink relationships. By exposing document metadata and hyperlinks, users can casually explore semantic relationships or browse collections with a variety of visualization tools. Workspaces themselves can be thought of as editable documents. Desktop snapshots can be saved to resume a task or keep a record of the key moments in a workflow. A query bar promotes casual exploration by using the Bing API to display iconic previews of related searches. Query results are shown in compact faceted lists. However, for richer visualization, these results can be dragged onto the workspace and viewed with special layout arrangers. Here, a smart arranger analyzes document metadata to cluster results into logical chunks. Different clusterings can also be explored. A timeline arranger provides insights into how documents were created or can be mapped to date-based document metadata to reveal other chronologies. Other visualizations can be selected, such as a customizable slideshow, a zoomable pane of icons, scrolling browsers, and more detailed property lists. To facilitate sharing, all WorkTop documents and desktops live in a cloud-based file store. A virtual Mylar layer preserves a workspace as temporary messages are added. The annotated workspace can then be sent to a contact in the integrated communication pane. This pane also displays previously sent or received messages. Removing the Mylar layer restores the original workspace. Workspaces and documents can also be edited synchronously in the manner of a shared whiteboard. For broader communication, informal arrangements of documents can be marshaled into structured publications. Dropping source material into a web publishing template creates a stylized web page. Alternatively, the layout of a workspace itself can be exported as a PowerPoint slide for refinement and inclusion into a presentation. When running on a pen and touch-enabled device, such as a tablet or electronic whiteboard, workspaces and documents can be annotated with digital ink. Multi-touch interaction is used to navigate and lay out a workspace. WorkTop features a set of pen gestures, such as a scribble delete, to remove unwanted content. Frequently used tools can be invoked from a palette created by a tap-punctuated rectangle gesture. Here, a map is selected. Alternatively, tools can be instead directly placed using mnemonic punctuation. A Bing search page is loaded directly. Instead of directly writing into small input prompts, full-size desktop notations can be linked to an existing control, such as a browser's search box. Alternatively, desktop notations can trigger API calls, such as to Wolfram Alpha. A lasso gesture tells the system to interpret and segment digital ink as tabular data offering spreadsheet functionality. A cell-crossing line gesture is used to pattern fill cell values, whereas regular inking is recognized as cell content. Dragging header cells creates cell or column references depending on context. Formulas can then be created by combining handwritten arithmetic operators. Drag and drop is often more efficient than the alternative of recognizing entirely handwritten expressions. Here the fill gesture extends the basic formula entry. Dropping a header cell to an empty space on the background displays a graph. Redrawing a line in the graph actually updates the values in the table. This inverse editing approach supports exploratory visual estimation and projections. To create rich visual illustrations that highlight dataset computations, free-form spreadsheet cells can be created anywhere on the page. Scrollable data viewers can render live views of SQL databases. Dragging out a column header creates a visualization of its data, such as a compact histogram or a recognizable contextual embedding. These easily understood visualizations can also be used to interactively filter the dataset. For example, selecting a histogram bar filters the dataset to show rows with values in this range. The inline graph viewer, on the other hand, allows the user to draw a representative curve which then filters the dataset to show only rows with similar data plots. Dragging out a column containing addresses displays a map of their locations. Circling a map region filters out all rows outside that area. For more complex analysis, these visual filters can be stacked into filter chains. Connecting filters vertically corresponds to a logical OR of their effects. Connecting filters horizontally corresponds to a logical AND. Here, two filters are connected to the same field, but the second sees only the remaining values and thus displays a finer histogram. If the first filter is changed, the attached filter automatically adjusts to the new range of values. Selecting a bar in the attached histogram further filters the dataset and updates the view. To compare the effects of two different filter chains, the user taps on either to toggle between their outputs.